So we've used the price elasticity of demand, and we've used the income elasticity of demand to figure out normal and inferior goods. And now what we're going to do is we're going to use what's called the cross-price elasticity of demand. And we're going to revisit a topic that we talked about earlier in the year. Actually, it's one of your basic concepts, and it's one of your demand curve shifters, or 2-year demand curve shifters, talking about substitutes and complements here. Cross-price elasticity of demand is going to help us determine whether or not goods are substitutes or complements. So what I'd like you to do is take a second right now, see if you can come up with in your head 2 examples of substitutes, 2 examples of complements, all right? Do that in your head right now. So here are my examples. I went with the classic Coke and Pepsi for substitutes, hot dogs and hot dog buns for complements. So the hot dogs and the hot dog buns, you buy one, you got to get the other, right? A hot dog without a bun, A hot dog bun without a hot dog, Coke and Pepsi work in a different way, where you would take one over the other. If you were at a restaurant, they didn't have Coke, you take Pepsi. They're interchangeable. But that's also not the only relationship that we have looked at with these types of products. But we've also asked ourselves what happens when, say, the price of Coke increases. Well, it affects the Pepsi, because if the price of Coke gets more expensive and they're interchangeable, then people will demand for Pepsi. They'll demand more Pepsi. But if we look at hot dogs and hot dog buns, if the price of hot dogs increases, just like the Coke did, notice what happens to the demand for buns. It does what? It decreases, because now people, they buy these together instead of interchangeably. People now buying hot dogs say, well, they're going to buy fewer hot dogs because price of, I didn't put hot dogs in here, hot dogs increases, the demand for the bun is going to decrease. And so notice, when we change our whole demand curve, every single quantity demanded at every single price point changes as well. So we're actually comparing how the quantity demanded of one product affects the price, or how the price change and the quantity demanded for the 2 different products interacts here. So this is a little confusing because you're not dealing with just one product anymore. It's not the incomes and then the quantity demanded of one product. It's not the price of one product and the demand of one product. It is the price of one product and the quantity demanded of another. This throws students off so much. So here is the textbook definition here of how the quantity demanded of one responds to the change in price of another. Here is the formula. Notice again, quantity demanded, QD is on top here, the percent change in QD. Quail delicacies always go on top over something. And you can always remember that. It's very helpful to keep QD on top. Otherwise, you're going to mess your answers up. And our answers here are going to tell us whether or not goods are complements or substitutes. So let's take a look. Let's just use our hot dogs and our hot dog buns. So we just did this over here. We said, hey, if the price of hot dogs increases, so let's go back. So if the price of hot dogs increases, change in price, how much do you want the price of hot dogs to go up? What do you want? 100%? Sure. Okay, 100% increase, right? Well, then let's see here. So the price of hot dogs went up 100%. Then the QD for the buns is going to have to decrease. So how much do you want it to decrease? Let's say 50%. Okay. The question is, though, it decreased. So how do we indicate that? That would be with a negative. So the answer would become a negative 0.5, right? And that's going to be a big hint to us. Because if it comes out negative like this, then we are going to have, or we should have, complements. So let's write that down. Let's write it. I'll pause, actually, so you don't have to watch me do it. So if it's complements, like hot dogs and hot dog buns, should be a negative number. But look at the relationship between our Pepsi and our Coke here. So here, the price and the quantity demanded went in the same direction. So let's see. So if we want to do this, if we imagine that instead the change in price of Pepsi was 100%, we would expect instead that the quantity demanded of Coke would be in the opposite. So instead of being a negative 50, and again, I noticed that I'm not changing my actual hot dog buns here, but it would be a positive 1/2 now. So this is what you get if there's substitutes. So, here, I'll pause again so you don't have to watch it. So, this is the relationship that you're looking for. So just like in the price elasticity of demand, it's more about the sign in front of your number and less about the actual number. And so if you can kind of think in generalities again about how the formula works, then you'll be more successful than really having to understand the actual formulaic entry of Q2 minus Q1 over Q2 plus Q1, so on and so forth. So with that in mind, let's go to the next slide on your slideshow here, and let's see if you can try G.I. Joes up here. Notice they give you the percentage change, so you don't have to calculate a percentage change. It's already given to you. You just have to set it up. So why don't you take a minute here, go ahead, try to set it up, and I will confirm it for you in a second. So go ahead, give it a try on your own first. So let's see here. I set up my equation here. I brought it over. So we put the change in quantity demanded of good 1 on top, the change in price of good 2 on the bottom. So let's see here. The price of G.I. Joes falls by 10%. Meanwhile, the quantity of Lincoln Logs demanded increases by 5%. Complements or substitutes? Well, let's see. I only have one price change, so that's got to go on the bottom. So price change 10% on the bottom. There it is. Quantity demanded change, got to be on the top. 5%. 5 divided by 10, I got 0.5 here. Good to go, right? So this it looks like we care about the sign, right? So this should be substitutes because it's positive. Whoa, 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 whoa. Wait just a second here. Hopefully you're saying, wait, Mr. Sutton, it says falls. So the price of G.I. Joe's actually went down a negative 10%. So there should be a negative in front. So these, in fact, shouldn't be substitutes. They are complements. And if you think about it, it makes sense. So the price of the G.I. Joes went down. So people are snatching up more G.I. Joes now. But at the same time, they're also buying more Lincoln Logs. So it stands to make sense that they're buying the Lincoln Logs and the G.I. Joes together. So they are complements here. Now, whether you agree with this or not is not the point. The idea is for you to see the math here. Because if we change this and instead of decreasing, we said it would, or instead of increasing for the Lincoln Logs, we said decrease, we would get negative 10 over negative 5, which would equal 0.5, and we would have substitutes where the price is falling. So again, it would seem that people were buying more G.I. Joes at the expense now of the Lincoln Logs. They're not purchasing the Lincoln Logs, which would give us a substitute-like relationship. So that matches with our rule. Okay. Now try this, and again, this is probably the most difficult one to understand. So try this one on the bottom here. It does. If you want to make up what good A and good B are, you can go ahead. You can say artichokes and bananas for all I care. But try this one right here, and I'll come back in a second and see how you did. Okay? Be careful. I am trying to trick you. So for this one down here, it doesn't give you the percentages. So you do have to calculate using your midpoint method here. So I need to find the percentage change in quantity demanded of good 1. Well, the question is, what's good 1 here? Is it good A or is it good B? Oh, how would I be able to know that? Well, I have to put the percentage change in price of good 2 on the bottom. Well, there's only one price here. So good A has to be good 2. So the information from good A has to go on the bottom. So I'm going to do that first here. Okay? And so I got to remember, I'm going to do, and this becomes very important how you do this. You have to be careful about which is going to be P1 and which is going to be P2 here. So I'll go like this. I'll say P2 like this. Just write it in. Okay, and this will be P1. All right. Hang on, let me take. So if you need to go back and check how you find the percentage changes, go ahead and do that. But I know 10 minus 8, P2 minus P1 is going to get divided by 10 plus 8 divided by 2. Okay? I know that's the bottom here. Now the top becomes crucial. You got to make sure that your P2 and your Q2 align here. So my quantity demanded of good 1, well, if good 2 is A, I don't want to use these numbers here. Because if you use these ones, you're comparing the price change of good A to the quantity demand change of good A. You're not finding the cross price elasticity of demand. You're finding the price elasticity of demand of A, which will tell you if it's elastic or inelastic, unit elastic, perfectly elastic, blah, blah, blah. So we want to use what's over here. So 5 is going to be our Q2. Okay? Again, it's important that P2 and Q2 match up. And this is going to be our Q1. All right? So now let's go to the top. So I'm going to do Q2, which is 5 minus 10 divided by 5 plus 10 divided by 2. Okay? And I'm going to spare myself the math here and you, and I'm just going to write this out here. Actually, at this point, why don't you go ahead and solve here, and I'll wait for you and see how you do. Okay? So, and determine if you think it's complements or substitutes here between these two goods. Go ahead. So I solved it out, got 5 over 7.5 on the top, negative 2 over 9 on the bottom. At this point, I can really stop because I know what the answer is going to be. I know that whatever it is on top is going to be a positive number divided by a negative number. So I know it's going to be a negative, and that tells me right away that these are going to be what? Somebody tell me. They're going to be complements because it's negative here. I think I came out with, at the end of the day, a negative 3. All right? So the bigger the number, the more complementary they are, I suppose, or the more, the better examples they are of substitutes if they're more positive, to try to make you think of that a little bit differently. So now your job is, you have, I believe, one more here. Okay? So now, G.I. Joes again and Lincoln Logs here in your chart. So show your work. We're looking for when G.I. Joes go from $2 to $3. What is the deal with G.I. Joes? Are they Lincoln Logs or are they Lincoln Logs? Are they substitutes or are they complements? So go ahead. I'm not going to go through that one with you. And then you have your other problems on page 525, 4, 5, and 6. But now you can do number 4. Okay? So I'll put that up there for you to remind you again. 4, 5, and 6. Okay? All right. Good luck. Let me know if you have any questions.